Welcome everyone to this last talk of this fifth edition of the Legacy of Socrates. I'm really thrilled to have Clare Macrae speak with us today. If you don't know Clare, she's an independent consultant. She's really expert into legacy code bases and helping companies deal with such code bases. I know Clare because she has been a very strong maintainer of the approval test C++. So together with Llewellyn Falco, every week she's keep maintaining that library. So if you are doing C++ and you want to do some approval testing, that is a very powerful technique I mentioned before. Basically, you should check out this if you don't already. And Clare is providing you with these tools. So really, she's into legacy code, and she's about to share with us some of her experience on refactoring, and in particular, how to leverage your tools to make this refactoring work safer and quicker. So, without further ado, Clare, the stage is yours.
Thank you very much indeed, Nicholas, and welcome to Refactoring Superpowers. So picture the scene. You've got a feature to implement in some code you've been working on, and you know how important this feature is for users. They've been asking for it for ages, and you know you're going to make them really happy. But you also know that the code wasn't designed to implement this feature. So even though your tests are passing, you're nervous about how much you're going to have to pull the code apart and try and fit it back together again. You think the tests might only be broken for a few hours. You think you can probably do it, but you're going to have to concentrate super hard and be pretty lucky. So yeah, you're feeling sad. Maybe you can get it to work, but the big risk here is it's an all or nothing change. Either it works, and you've probably got a bunch of debugging to do, or you run out of time, you throw the change away, it's incomplete, and you've made no progress. This talk is about an alternative to that. It's about how to be kind to yourself, your colleagues, and the future maintainers of your code, not to mention getting the feature out quicker to your users as well. I'm Clare Macrae. I have been programming for a living for 30 years and in C++ for more than 20 of those years. My main background is in chemistry, and I've done a lot of work on crystal structure visualization. As was just mentioned, a lot of my work in recent years has been volunteering on the approval tests library for C++. And I've used other versions. It's available in many languages. My real focus has been on learning to work better with legacy code, testing and refactoring, and a lot of my time is now going into sharing what I've learned via conference talks and training and things like that. This is how you can contact me. And my Twitter handle is at the bottom of most of the slides as well. So my goals today are threefold. I want to inspire you to explore the techniques that I'm talking about, and the earlier speakers have talked about as well. I want to inspire you to experiment with your own code bases and with katas as well for practice. And practice is the key thing. So to use these techniques until they feel comfortable and automatic for you. The talk is divided up into three themes, really. It's about tactics of refactoring. A lot of it is about maximizing the help that you get from your IDE, your development environment. And it's about making the changes safely so that you're guaranteed that each change is an improvement that you can keep. So let's talk about refactoring. What is it? Well, essentially, it's restructuring existing code. It's about keeping the behavior the same. And both of those things are really important. So it's not about fixing bugs, and it's not about adding features. And there will at times be a temptation when you're refactoring, when you spot what may well be a bug and you might want to fix it. There's two reasons not to do that. It's going to derail you from the refactoring, and you're going to have to go and have a conversation with somebody to establish, is it really a bug or has it become an accidental feature? So generally speaking, refactoring is things you do in order to make fixing bugs easier and adding features easier. So the high-level process is you see a smell, you see something you don't like, and you make a safe change, a small safe change. You run your tests, and then you commit the change. And as Nicholas said earlier, you want to commit little and often. And you repeat until you're done. What smells? Well, I'll touch on a few smells as we go, but it's things like long methods, unclear names, missing encapsulation, concepts missing from the code, that kind of thing. What do we mean by safe changes? I'll talk about that shortly. And when am I done? That's really important as well. It's important to be aware of knowing when you're done. I'll give you some tips on how to do that. Let's talk about safety first of all. Where does safety come from? Well, the first place it comes from is your IDE, your development environment. And if it's a compiled language, the compiler within that as well. So I will give you some examples later on of using IDEs to make changes. But the idea is that people who work on these development environments have spent huge amounts of their time understanding the languages that they support and how to add capabilities to those development environments to make those small edits and to make sure they're safe, and to only present them as capabilities to you when they're safe to do. So by using your IDEs to make these changes, you're really standing on the shoulders of other people's work. Of course, your tests are a big part of the safety as well, and it's important to understand how good the code coverage is. Occasionally, you might need to be doing manual testing initially. That's fine. Try and automate it as soon as possible. And so I would be looking at only running the relevant tests. If all my tests are too slow, then I'd be filtering to only run the tests that are likely to be relevant during my refactoring, and trying to set up a mechanism so that every time I save the code, it's built and it runs. So really, really fast feedback cycles. And of course, version control as well. And Nicholas, in his talk, talking about making micro commits and perhaps over committing, said this fantastically well. By committing little and often, you keep your concentration, you keep your flow, and if you make a mistake, it's really easy to go back in time. You can always create a new little branch to try a different approach. Gives you lots and lots of benefits. So what does that look like? Well, we're making a micro refactoring. And when we've made the change, or as we are using the IDE to make the change, we review it. And then we run our tests, and then we commit the change, and then carry on to the next small refactoring. But let's explore that a little bit. If you make the change, and as you make each change, as I make each change, I think about, is that a small improvement? Does that make the code a little bit better or a little bit worse? So an example might be if I've extracted a method and the IDE says I have to pass in 7 parameters and I'm returning 3 things, that tells me that's probably not the right amount of code that I selected in the first place. So usually I will actually like the change, but if I don't, then I'll revert. I won't spend time manually fixing it. It'll be quicker to revert the change and do a different refactoring. And my concentration stays on the job if I go back and try a different refactoring rather than trying to manually fix it. Then I'll run the test, and of course, if they fail, I'll revert. I won't try and fix the test manually. And if the test passed, then I go ahead and commit. And this is how we know that each change is safe. So now let's look at how we're actually going to do the work. I love this quote from Kent Beck. For each desired change, make the change easy. Warning, this may be hard, then make the easy change. So I'm going to explore that and what that means. Big shout out to the Refactoring book, which by Martin Fowler, with some content by Kent Beck as well. And it's been mentioned multiple times today. It's a really powerful book. This is the 2nd edition, which was released in the last year or two. It's had quite a major update. You may not be aware, but there's a sort of sibling website to that called refactoring.com, and refactoring.com is a free website. You don't need to log in, and it provides searchable summaries of all of the refactorings. You can search by tag and things like that. That basically gives you cryptic pictures describing the refactorings, but also the names of the refactorings are useful, so you can Google for more information. But if, when you buy the refactoring book, you get the web edition as well, then the catalogue, refactoring.com, has links to the multiple pages of detail for each of the smells and each of the refactorings. So these things tie together really powerfully and really convenient. A big shout out to Sabrina in her talk earlier today. A refactor a day keeps the rewrite away. So it was a great talk on rewriting incrementally and how to avoid needing big bang rewrites. So obviously I'm talking about more than a single refactor, but the general principle here, I'm talking about refactoring as a process in its own right, but ultimately you'll be building it into your daily work. This started off as a talk about refactoring, but it's actually ended up to some degree being a talk about flow. So flow is that state where you're relaxed and you're focused on what you're wanting to do, and it's not hard making changes. So it's about ways to program at the level of intent rather than how do I make lots of small manual steps along the way. Sometimes your IDE won't be able to help you and you'll need to drop down to manual edits, but you want as much as possible to be programming by planning your next intention. Now, I wanted some example code for this, and for reasons that I'll explain in a minute, I ended up picking Sudoku as the example. So this is what a Sudoku puzzle looks like, and it's essentially a number puzzle where you start with an incomplete board and you need to fill in the gaps, 81 digits. And basically each of the digits 1 to 9 appears once and only once in each row, column and small box. If you haven't seen that before, the details don't matter for the purpose of the talk. So whilst I was looking for example code, I found this lovely video by Zoran Horvat. It's a JetBrains webinar from about 4 years ago, refactoring a 1,000-line method into cleaner code. And the way he works in this video is that he leans on the compiler. So he makes the change, he essentially breaks the code to move it around, and then if the code compiles, he's happy and he moves on. And somebody asks in the Q&A about testing, and he says, that's a subject for a separate talk. And that became the starting point for this exercise. Is could I add tests to this code, and then how would I refactor it in small, safe steps? So he describes it as coding practice demonstrating an awfully long method, and that's Zoran's words. He's a trainer, so he's written this code to be deliberately smelly, but it's a fantastic example. Try to refactor this 1,000-line long method. It happens to be in C#, and I'm mainly a C++ developer. So this was really my first C# experience. It was interesting how far I could get by using IDEs that did the work for me. This is the original IDE, sorry, the original URL, and this is my fork of it. I'll provide an easier way for you to get to those links later on. So my first step was to add tests because there weren't any tests in the code. And so the first thing I did was to run the program, and it generated some console output, and some more console output, and some more, and then finally 800 lines later it finished. So that immediately tells me this is really suitable for approval testing because it's already generating text output. And so this talk isn't about approval testing, but I wanted to show you what the code I ended up with looked like. So here is my test. So it's in C#, so it's fact should do the same thing twice. and it's generating console output. And so I Googled how in C# to capture the console output. It turns out to be wonderfully easy, so that was great. And the class is called program and the method is called play. And it turns out that when you call it once, you get some output, and if you call it again, you get some different output. And that's because it's using a random number to generate a variety of puzzles. And so I Googled how to pass a seed into a C# random number generator. And I found that by passing 10 different seed values in from 0 to 9 and using code coverage, I covered all paths through the code. I tried breaking the code and all some mutation testing. I found all the failures. So that's my test. And then I take the accumulated log output from those 10 calls and run them through approval tests. So essentially, this was the initial code. The underlined means it's static methods. So it's a class called program, and there was a static play method. And I changed it so that the play method was public, and it accepts a random number generator, which I can choose to put in a seed. So with that small change to the code, which I was able to do with an automated refactoring, I had really good test coverage. If you want to know more about approval tests, here's my most recent general talk on approval tests from CPPCon in 2019. So that's all very exciting, and now I can go ahead and do my refactoring. And in fact, that's what I did. I spent several days on and off refactoring the code and experimenting with it. And at some point along the way, somebody pointed out to me something that I kind of knew already and I'd forgotten, which is if you refactor without a purpose, you end up in this kind of bottomless pit, renaming things, moving them around, dividing them up. And there comes a point when you're making changes, but not really improvements. So how do you avoid the refactoring bottomless pit? And the number one thing is to know the purpose. And in fact, for the refactoring to be done to support the purpose. That might be fixing a particular bug. It might be adding a particular feature. And I suspect that's the most common use of it. But I've added one as a result of Adam's talk earlier today. It might be that you're running some code analysis and there's some organizational risk that you've discovered. There's some hotspot, complicated code that needs to be changed all the time. Maybe you address that the next time you make the change in that area, or maybe you decide that the hotspot in itself is a big enough goal. Pick any of those. So for this talk, my goal is going to be to change the code to allow it, so I can use it to solve puzzles set by others. That's my goal. So don't be tempted to read the code on the next slide. This is the awfully long method that Zoran created. And you might have noticed the indentation and the nesting that goes along. And Adam mentioned heavily nested code is a great clue for risk and complexity. It turns out there's just over 1,000 lines in the original code. So there's a lot of scope for refactoring, and that's why I disappeared into a bottomless pit. But now that I have a goal, what do I do with it? Well, the first thing to do with a long method is to extract chunks of it out to a method or a free function, whatever's appropriate for your context. So C# has this idea of regions. You can put comments in that say begin and end and give regions names. So you'll probably find the code that you're looking at has either got comments that show you the start of chunks or maybe regions. But either way, I've collapsed the code down and I found that I've essentially got 3 chunks of code. Line 13 and onwards construct a full board, all 81 digits filled. 193 onwards, delete some digits and put some blanks in, and then 244 to nearly 1,000, solve the board. So since I want to be reusing the solve the board code, that's what I'm going to extract out. And most of it's in that while loop, you can see. You don't want to see the detail. So I've selected the code that I want to extract, and then I click on the little, I'm not sure what you call it, the brush icon or something at the top of the selected code, and it pops up this menu, and I say refactor this, and then I say I want to extract a method. And in the blink of an eye, even for those 800 lines of code, this dialog pops up, extract method. And it shows me that the IDE has analysed the code and it's found 4 things that were declared before the chunk of code that I'd selected. So they need to be passed in. So it's saying, I recommend you pass these 4 things in as parameters. It's also found some things that are declared inside the block of code and that are not used afterwards. So I could return them if I wanted to, but there's no need to. And it's found nothing that gets used after. So the return type is empty. I could reorder the parameters if I wanted. I can select them and move them up and down, or I can do that as a later step, which is what I tend to do. I can choose whether to make it private or public or protected. I have no option to make it static or virtual, or make it not static, and that's because I'm extracting from a static method. So all of these things, the developers have done the work, the IDE developers, so that I don't have to think about them. And then it shows me a preview. And this would be, if I cancel here, if I don't like the choice of parameters, for example, then I would cancel, go back, and perhaps start with a different selection. So people sometimes say to me, but this is stopping me learning about the code. I'm not benefiting from this. And the point I would make is it's actually teaching you about the code. It's teaching you about the structure, and it would take ages to work this out by hand. By the end of it, we're going to have a smaller chunk of code that we can then reason about a bit more, divide up more. So I like it. So the last thing I do is give it a name. I try to make the name descriptive if I can, based on the comments and the information, even if it's, does this and this and this and this and this, because I can improve the name later on. So this is what we started with. We had our static public play method, and we've now introduced a new method, which initially is private, called solveboard. Now, I decided that I wanted to make a further improvement because the parameters that were being passed in, they feel like implementation details. This state array and board array and final state. I don't yet know what they are, but they don't represent any concepts. They're primitives, basically. And so I used a facility called transform parameters. And that allows me to group things together from the inputs into a new concept, and to group things together from the outputs and wrap them in a new concept. And so here I'm saying I don't want to group the random number generator. That's separate. That's not part of the domain. But whatever these things, state, board, and final state are, they feel from a glance at the code like they're related. So I will turn off the checkmark on random, leave the other 3 turned on. I'll say make it a new class with public fields for now. I can encapsulate them later. I'll call it grid, and that's it. And so my solveboard will be modified, and the calling code will be updated for me automatically. So this is what we've got now. We've got our new class grid, and the parameters to solveboard have changed. So these are small, simple changes, but already we're starting to see structure in the code. It turned out that that board character array was derived data. It wasn't fundamental storage. So I created some helper code to write that on demand. I called it grid Stringifier, and that enabled me to remove the board field from the grid class. So now code that uses this class doesn't have to worry about managing that character array. Now remember the original quote, for each desired change, make the change easy, then make the easy change. But it turns out that those few steps were all that I needed to do to be able to add the code to solve a grid. remember that the first times when I went through just experimenting without a purpose, I spent hours and hours and hours, created multiple different branches, exploring different approaches. Well, I learned a lot about C# and refactoring, but I didn't get closer to solving this problem. So I used a site, websudoku.com, to give me an easy puzzle, and it's 81 digits here, and the zeros are blanks, they're numbers to be solved. And then I fed that into another website that told me the solution, because I certainly wasn't going to solve it by hand to write my test. And that's a nice thing about the test, having independent data as well, as I'm confident in it. So that's my input and my expected output. So then I wanted a grid.solve method that I could pass the input. I maybe didn't need to call to string there. And that's my assertion. So I don't even need approval tests at this point. I can write a nice, simple, vanilla unit test. Now I need to actually implement the feature. And this was all the code that I needed. So I needed a constructor for the grid that took my input string. And I'll do a sort of vanilla assertion for now. I won't worry about error messages or anything like that. Create my integer array. Turned out the final state wasn't needed so long as the board had a unique solution. So I just made that empty in 81 zeros. And then grid.solve. I got my solve board method that I extracted in the previous step. So that was it. That was 800 lines of code separated out. Now, it won't always be that easy, I admit, but by having a goal to focus on, it took me down the path I needed to go. So was it worth the time? Was it worth using that mechanism? Absolutely, it was. I usually find that when I'm doing automated refactoring, the worst is it takes about the same time as it would have taken me to do it manually. Usually it takes less time than doing it manually. But because I was able to commit at every stage, even if I fail at any point, I've made the code easier to maintain, I've improved names, I've encapsulated what I've learned. So yes, it's worth it. Now I'm going to move on to talking about IDEs, integrated development environments. And I'm going to spin through the rest of the talk really quite quickly, because I want to show you capabilities and to give you ideas. There isn't time to go through them in a lot of detail, but I think some of the techniques will be new to some people here. So the first thing to say is whatever IDE you're refactoring in, it really matters where the cursor is or what the selection is. So don't be disappointed if you try to make a change and extract method or rename variable isn't there. Explore and find out how to access the refactoring tools. There are two other techniques, though, that are not obviously refactoring, two other capabilities, but they're worth knowing about. Quick fixes and generating code. So let's talk about generating code. At some point, I had a class called game, and I wanted in my test to say was game1 equal to game2. I didn't know how to do that in C#, but the IDE I was using had generate code capability, and it allowed me to generate equality methods. Now, if you already knew how to do this in C#, it would still be a bunch of typing. If you didn't, it would be a whole lot of Googling. That took 30 seconds to do or something like that. Similarly, quick fixes to clean up code. At some point, I ended up with a parameter line1 that was no longer used. And previously, I think I would have deleted it by hand and then found all the code that didn't compile. But it turns out that you can say quick fix this, and it says remove unused parameter and update uses. So all the time I'm working towards thinking, I want to just remove line 1. I don't have to think about the mechanics of doing it. If at all possible, I'll try and let the IDE do it for me and commit at every stage. Another way to use quick fixes is to get them to write the code for you. This is one it's easy to forget about, but it's super powerful. So I wanted to write, I wanted there to be a method on program called solve grid with unique solution. wasn't the name I ended up with, but this was during one of my experiments along the way. So I wrote it, and the IDE said that doesn't exist, and it displayed it in red. And then I used the quick fix, and it said, okay, I'll create it for you. I still need, it offers me a default return type, default input, and it does the safe thing of its implementation initially throwing. So you find out, you get feedback if you forget to do the implementation. So getting the IDE to actually write your code for you is a really, really great time saver. Now, multiple times I've said your IDE, but really I should be saying your language as well. Depending on where you're working, you will know your IDE, you will know and different IDEs have different capabilities for different languages. I learned during this IDEs have much richer refactoring capabilities for C# than for C++, which is fair enough. C++ is a harder problem, but I started to understand why some former colleagues had enthused so much about C#. Development tools differ. If you're using Notepad or something like that, I really encourage you to spend the time to pick up an IDE and get familiar with it. That will do a lot of these things for you. And experiment and practice. Speaking of practice, it's really worth getting to know the keyboard shortcuts for your IDE. And for the last couple of years, I've been working on a Mac. And so I had to learn keyboard shortcuts like this, so Command and Alt and so on. Because C# is so commonly used on Windows, I thought I had to find out how to do these things in Visual Studio as well. And there I found a completely different set of shortcuts. And I'd always steered away from these two shortcut sets. I think they're called chords, but Control R and then another character. So Control R and then R for rename, or D for delete, or O for move. That's the only one that's slightly less obvious. But as I got to use them, I found it made it much easier to memorize the individual shortcuts. And if you compare that with the Mac version, only these three on the left actually are memorable: introduce variable, field, and parameter. So the sad thing is I completely broke my muscle memory writing this talk, and I've had to work on getting it back. But at the higher level, more practical recommendation is be aware that there are different shortcuts, and be aware that any IDE worth its salt will allow you to select from a range of commonly used, common sets of shortcuts. So pick one, become familiar with it, and as you switch between platforms and IDEs, go to the settings and change it so that it uses the one that's in your muscle memory. You'll be more productive and you won't have to keep relearning things. I'm going to talk briefly now about adding abstraction. So I think in practice, my experience of refactoring legacy code, one of the most common problems I encounter is the code is written in terms of low-level primitives. I think it's primitive envy, I think is the common name, but primitive obsession, I think, is the name of the smell. And the idea is that, yeah, the concepts of the domain are hidden in the code somewhere, but everything is expressed in terms of ints or characters or strings, floats, doubles, whatever. So when you're refactoring, often what you're doing is trying to find out where the domain concepts are hidden within the code, and tease how to pull the code apart, explore how to tease the code apart. Now, my starting point for this is another great Kent Beck quote: if you're ever stuck wondering what to clean up, move similar things closer together and different things further apart. And that turns out to be a really powerful observation. So imagine that you are working on a class that's got lots and lots of methods and you're trying to find the concepts. Well, reorder the code, reorder the methods, reorder the fields, so long as doing so doesn't change the behaviour. Move related things closer together and unrelated things further apart. That will start giving you clues as to what the concepts are. You can do that based on names, you can do it based on parameters, return types. So imagine you've got a class rather, called extract field, and it has a horribly long method, and buried in that long method are 3 integers that are going to end up representing or being grouped together into some object that represents some part of the domain. What you can do is you can use extract field. And so what I've done in the IDE is for each of these things, thing 1, thing 2, thing 3, I've said, move this down into a field. Happens to be a private field at this point. Now you might be thinking at this point, yeah, but it's good practice to reduce the scope of things. And here I've increased the scope. That's now accessible to every method. But don't worry, it's a step along the way. The behaviour would be different if the method I was refactoring from was static. Then my new fields would be static. And I found in preparing this talk that often the refactoring was easier if the methods and the fields were not static, if they were specific to instances of my class. And so you might consider, if you're only dealing with static data and static methods, you might consider adding a non-static overload. It might make your latering steps easier. So now I've got these fields that were encapsulated, but they're used directly everywhere. So the next thing I'm going to do is encapsulate them. So select a field and say encapsulate. And in C#, there happen to be ways in the language to make them various options as to how you do that. And in the first one, I said make it an auto property, and the details don't matter. Find out in your language how to encapsulate things easily, or learn the pattern to do it by hand. And then finally, I'm ready to actually extract a class. So I've ended up with 2 fields, concept 1 and concept 2, and 2 or more methods that use those specifically. So I can use extract class, and in the checkbox, I'll say I want to extract out concept 1, the field, and concept 1 function, the method. And similarly for concept 2. And now automatically the IDE has updated my original code to use those separate classes. Now, before, I spent ages doing that by hand. It never occurred to me that those kind of capabilities were built into IDEs. So a few tips looking back on that. It really matters whether you're refactoring something that's static or not. Don't assume that you have to move things from an existing file or an existing class. Try and break the tool. Try and see if when you say move, you can give it a new file name, and it just does it. It'll probably do it for you automatically, and it will update your solution or your project or whatever. It's amazing what they can do. And in some languages, you can also take a static method and make it non-static and say attach it to this class that perhaps was passed in as a parameter. Now, at the start, I mentioned flow. Let's talk about flow a bit more. I often find that when I'm programming, I'm typing the same few lines of code repetitively. I'm doing or creating files. Now, I create a new class, I create a new test file, and so on. I'm quite an impatient person. I get really frustrated if I have to do things by hand, partly because of time, mainly because of lack of concentration, but also because of the chance of there being errors as well. And so I saw this pattern of this kind of file that I was creating. And so I used save file as template, which many IDEs have. And so I gave it a name, XUnit JSON approvals test, and I put in a parameter, a variable in the template, which you'll see in a moment how I use that. So again, I'm trying, at this point, my goal is to let you know about these capabilities rather than to go through it in great detail. So I've created the template, and now when I want a new test, I can right click and say add, choose the name of my template, and it says, what do you want the file name to be called? And then it creates, on line 6, it's created a test class of the same name. And I wanted to really draw your attention to line 9 here. So there's two things going on. To encourage me to think about a test description that describes the purpose of the test, I've begun the name with should. Because I've learned through experience that's an easy way to think about starting a test name. But then I've made sure that the code doesn't compile by putting spaces in the template. So I've made it easy for myself to succeed and hard for me to forget to change the template. Because how many times in the past have I created tests that say to do update test name, and then they litter my code base. That was with a whole file, and there's a similar thing with contents within a file. So I was creating new test cases often. So I selected that code, it said save as live template, and much the same thing, I gave it a name fact. And then as I started typing fact in the IDE in C# files, it offered this completion, and it even showed me a picture of what it was going to expand to. And it even left the cursor in the right place so that I could start typing the test name, and I made the test fail so at 1 = 2. So there's no chance that I forget to update it. So live template files and live templates are really powerful. So it's about flow. It's about practicing to get proficient with these things and learn how they work, but it's also about getting proficient with the tools themselves. So to find out more about the things that I've talked about, I've set up a bit.ly link here, and that jumps to a page on my website which lists all my past talks by topic. And this is the second time I've given this talk. As videos are published and as slides are shared, I add the links to the slides in the video. But I wanted to draw your attention to the links on the right-hand side there. So from that goes to a page on my GitHub where I've got a load of references to do with this talk, and that will evolve over time. So a quick summary of what I've talked about. I really want to stress the benefits of using refactoring tools. On a personal level, you'll be less tired at the end of each day by getting the IDE to do your work for you. You'll be confident that the behaviour is unchanged, and more importantly, the business and the users will get the feature sooner. And my message overall to you is explore your IDEs, refactoring features, auto fixes, automations. Each small amount of time that you spend improving your knowledge makes you faster and more effective, and that pays off over time. But also each small amount of time that you spend on streamlining your work, that also pays off. So it's a bunch of virtuous circles. It's very exciting. Practice refactoring difficult code and know how to use safe steps to transform the code. And it turns out that those things are really the superpower. It's the flow, the fact that you can program at the level of intent rather than small detail. That turns out to be the superpower and a way for a much more satisfying development life. Thank you very much indeed.
Thank you, Claire. That was great. There's a lot of good stuff that you shared here. And yeah, I totally, definitely agree and support everything you said, because that's surprisingly a lot of people I work with, they didn't know their tool so much. And yeah, refactoring, for example, I say something like extracting a variable, like putting some constant into a variable. yeah, you can depending on how you do that, it can take you a dozen of seconds, and you may do mistakes, or it can be instant,
Yes.
and it's night and day. It's also like you think about doing the refactoring, you think about transforming the code, and you have no friction. It appears in your editor because you know how to use it. You have the muscle memory and all of that.
Yeah.
Versus, oh, you need to do it manually, and it takes time, so you don't do it.
Friction, that's a really good word, avoiding friction. I like that. Thank you very much.
Yeah. So we have one question, and then I think we're gonna wrap up the conference. One question is, do you know a source of refactoring katas that can be done strictly using IDE automated refactoring features? Or would you say that any refactoring kata could be done in this way?
So it very much depends on the language. I do know. So I think a lot of the refactorings are provided in multiple different languages. So the same changes to make. And I think it would be very unwise of me to say you can do all of them in an automated way. But I do think they can all be done in safe ways. And in that bit.ly link, Refactoring Superpowers, I linked to a website that talks about provable refactorings. So a thing I should say about safety is it very much depends on your context. So if you're working in, I don't know, medical equipment or flight software or something like that, you're going to have a very much higher standard of safety. And so you have to know your context and what your field, your domain demands. And if you need to be absolutely guaranteed with safety, then the provable refactorings provide incredibly detailed ways to go through and absolutely guarantee that, for example, in C++, you don't accidentally create an additional copy of an object that behaves, and that changes the behavior of the code. But Googling for katas for code to practice is a really good thing to do in general. And it's a way to learn different languages as well, to try out different languages. You try it in one and then try it in a different language.
And then it could be a good exercise, like pick a kata and try to use your editor to do that.
Yeah.
Agreed. It depends on the language, of course, because not all languages have the tooling that brings these capabilities. I know what would you say the best languages are, in your experience, the one you...
I don't really want to get into language wars.
No, I don't mean best, but I mean the one that you feel you can do more
I would say
refactoring.
So comparing the JetBrains tools for C#, Python, and C++, which are the ones I've used the most, Python has more refactoring capabilities in those tools than C++, but C# has significantly more than Python. There are some commercial refactoring tools that they cost proper money, but they say that they provide many more capabilities than the kinds of things I've demoed now. And so if I was working in a commercial environment and I found that my productivity was affected by not having good coverage of refactoring tools, then I definitely look for alternatives that are available. Again, it depends on your scenario. Nicholas, could you tell us about the tool that you've been writing?
Yeah, I'm working with VS Code and mostly in JavaScript, TypeScript, and you don't have much refactoring capabilities, especially if you compare with JetBrains like WebStorm. I used to use this. We're not using it anymore. So I decided it will be fun also to learn more about the refactorings, and I'm creating a plugin, an extension to support these automated refactorings. It's called the Bracadabra. I will put the link in the chat. But yeah, if you use VS Code and JavaScript, TypeScript, give me a sec. Up. yeah, you may have a look at that. And yeah, it's very fun to be on the other side and building such tool because you really need to dig into what a refactoring is and work with the language. Bottom line, it depends on your language, it depends on your tool. Explore what you have, and you might find surprises, and it might worth the money if you have yeah, you have paid solution. But if you're working for a company, the time that you will invest here, the money you will invest here will be paid off with the time you're saving for every developer. All right, that's
Thank
it.
you.
Thank you very much, Claire. It was
Pleasure.
very
Thank you very
good.
much.